Concatenating data frames in Python, typically using pandas, means combining them along an axis. This is crucial for integrating data from multiple sources or stages, building comprehensive datasets for analysis. The primary method is pd.concat.
You can stack data frames vertically, adding rows. Using axis equals O, this is the default behavior. Or, combine them horizontally, adding columns. Using axis equals 1. Like pd.concat, def_features, def_labels. Axis equals 1. Use axis equals 0 when appending new observations or records.
Use axis equals 1 when adding new features or attributes that correspond to existing rows. While def_append exists, pd.concat is preferred and more versatile. Understanding these allows efficient data preparation and manipulation in your workflows.
The code first initializes 4 sample Pandas DataFrames. def_users_group_ or def_users_group_b, def_product_info, and def_product_prices. These data frames are designed to illustrate different concatenation scenarios effectively. def_users_group_ or and def_users_group_b share identical column structures, making them suitable for vertical, row-wise concatenation. While def_product_info and def_product_prices share a common index, ideal for horizontal, column-wise concatenation. The first concatenation example demonstrates row-wise combination using pd.concat with its default axis equals 0. This operation stacks def_users_group_b directly beneath def_users_group_a, resulting in a data frame that includes all rows from both. This method is crucial when aggregating data that shares the same structure but originates from different sources or time periods, such as combining quarterly sales reports into an annual one. The output shows how the original indices are preserved, leading to repeated index labels. The second example also performs row-wise concatenation but introduces the ignore_index equals true parameter. This is a common and important practice when the original data frame indices are no longer meaningful after combination, or when a clean, continuous index is desired for the newly formed data frame. The resulting users_combined_new_index data frame has a fresh index ranging from 0 to 3. Simplifying subsequent data processing and analysis by providing unique row identifiers.